Have you ever stopped to think about what connects the life-saving intelligence in your car's brakes with the crazy precision of a robot on a factory floor? Well, we're about to pull back the curtain on a hidden technology that powers our entire modern world. It's kind of like the invisible force that makes our machines smart. So let's kick things off with a little puzzle. Take a look at these three things: a high-performance braking system, a huge industrial robot, and a life-changing prosthetic leg. I mean, they couldn't be more different, right? So what's the common thread? And this just shows you the incredible range we're talking about. On one hand, you've got the absolute peak of automotive tech, built for pure speed and control. And on the other, a device that gives someone the ability to walk again with amazing sophistication. They seem like they're from different planets, but they're actually built on the exact same core idea. And the answer is Mechatronics. That's it. It's the ghost in the machine. It's a word you might have heard thrown around, but its impact is so much bigger than most of us realize. It's the design philosophy that has quietly changed, well, pretty much every piece of tech we use. Okay, so what in the world is Mechatronics really? To get how it powers everything from our cars to our cameras, we've got to deconstruct its blueprint. Let's dive in. All right, here's the textbook definition. Mechatronics is the synergistic fusion of different engineering fields. Now, that word synergistic is so important here. It's not just about, mashing these fields together. It's about blending them so perfectly that the final thing is way, way more capable than just its individual parts. This diagram is the perfect way to picture it. You've got mechanics, that's the physical stuff, the gears, the motors, the structure. Then you have electronics, the sensors, the power circuits. And finally, you've got information technology, the software, the control logic, the brains of the operation. Right there in the middle, where all three of those worlds meet, that's the heart of mechatronics. It helps to think of a mechatronic system like a living thing. Every single one has these four building blocks. The mechanical parts are its skeleton and muscles. The electrical components, that's like the circulatory system delivering power. The electronic components, things like sensors and controllers, are the nervous system gathering all the information. And the software? Well, that's the brain, making all the decisions and telling everything else what to do. So we have all the parts, but how do they actually come together to create a system that can sense what's going on around it, think for itself, and then do something? The secret is right here in this diagram. It's called the feedback loop. This is how the system thinks. First, you've got sensors out there gathering data. Could be temperature, speed, position, anything. That raw data gets cleaned up and fed to the controller, the brain. Based on its programming, the controller makes a split-second decision and sends a command to the actuators. Those are the motors and hydraulics that actually make something move. That action changes the environment. The sensors pick up on that change, and the whole loop starts all over again. This constant loop is what lets the system adapt in real time. It's pretty amazing. And that leads us to a really, really important point. Mechatronics isn't just a bunch of technical skills. It's a philosophy. It's a completely different way of approaching design. So instead of building a mechanical thing and then trying to figure out how to control it later, you design the mechanics, the electronics, and the software all together right from day one. And this table just shows you why that philosophy is a game changer. I mean, look at the difference. Old school conventional designs are often bulky, super complex, and can only do one thing. But the mechatronic approach, it gives us systems that are compact, way simpler, and, this is the really cool part, they have learning abilities. We're talking about a shift from a machine that just does a task to one that can actually get better at it over time. All right, so we've covered the what and the how. Now for the fun part. Let's go on a quick world tour and see this tech in action all around us. The automated factory is, of course, the classic example. These incredibly precise robots are the absolute backbone of modern manufacturing. They build our cars, our phones, our computers, and they do it with a speed and quality that's just impossible for a human to match. And hey, we're back to our car. That anti-lock braking system, or ABS, is a perfect mechatronic system. It senses if a wheel is about to lock up, the controller instantly figures out the perfect amount of brake pressure to release, and an actuator makes it happen, all in a fraction of a second. That, plus things like traction control and engine management, is what makes modern cars so incredibly safe and efficient. And the applications don't stop there. They even reach for the stars. I'm talking about everything from delivery drones zipping around our cities to rovers navigating the surface of Mars. Their automated navigation systems rely completely on mechatronics to sense their surroundings and make critical decisions in some of the most hostile environments you can possibly imagine. But it's not all giant robots and spaceships. It's right there in the palm of your hand. The autofocus on your camera, that is a perfect, tiny little mechatronic system at work. It senses distance, it processes that information, and it tells a tiny motor to move the lens into perfect focus, all before you even press the button. So, it's pretty obvious this technology is already everywhere. But honestly, this is just the beginning. The next huge leap is all about connecting these intelligent systems together. There are three huge trends that are shaping its future. First is the integration with the Internet of Things, or IoT. This is going to connect all these smart devices into these massive networks, creating truly smart factories and smart cities. Second is sustainability. Mechatronics is absolutely key for designing more eco-friendly and energy-efficient machines. And finally, a really big one, cybersecurity. Because when everything is connected, protecting these automated systems from hackers becomes one of the most important challenges we face. So, at the end of the day, mechatronics has grown up. It's not just another field of engineering anymore. It has become one of the primary engines of progress, a fundamental force that is actively building the world we live in and the future we're headed towards. So, as this ghost in the machine gets more and more powerful, making our world smarter and more connected every single day, I'll just leave you with this question to chew on. What is the one global challenge, the one big problem that you hope this incredible fusion of technology will finally solve next?